Hello there, and welcome to this video on parallel and perpendicular lines. So you may have heard of the words parallel and perpendicular before. Parallel just means that the two lines are going to face the exact same direction. So it would look something kind of like that. They're both facing kind of up and to the right. And then for perpendicular lines, these are lines that make a 90-degree angle. So they would look something like that. So in today's lesson, we're going to have lines where sometimes they might be parallel and sometimes they might be perpendicular, or they could also be neither of these two cases. So we're going to first begin by looking at this investigation. So we are going to graph these equations that we have down here. Now each of the equations is actually written in the form y equals mx plus b. So I'm just going to write that over here to remind you, y equals mx plus b. Where the m, that was the slope, and then the b, that is the y-intercept. So I can see that the slope for this one is that right there with the x, and then my y-intercept is the 2. So if I wanted to plot that first line, that first equation, I'm going to do it in red. So my y-intercept is at 2, so that's going to be right here. And then my slope is 2. So if you have a slope of 2, 2 is like 2 over 1. So you're going to rise 2, and then you're going to run 1. So I'm going to rise 2, 1, 2, and then run over 1. So we get another point right there. And then you could do this again, rise 2, run 1. And then after, just take your ruler and then draw a line through your points. And then always make sure to put arrows on the end of your line. So our first one is done. We're going to look at this blue one here next. So the slope is this right here. The 2 is really like 2 over 1, so it's the exact same as the last one. But our y-intercept is negative 3. So let's plot our y-intercept. That's down here at negative 3. And then I'm going to move my rise amount. So I'm going to rise 2, 1, 2, and then run over 1. So it gets us to there. And then do it again, rise 2, run over 1. And you could keep continuing this, but again, you only need 2 points, and then we can take our ruler and draw our line. And then draw our arrows on the end of that line. So we can see with this red one and the blue one, they seem to be pointing in the same direction. So those ones are going to be parallel. Next, we can look at this green one here. So the slope for that one is this negative 1 over 2 in front. So it's negative 1 over 2. So our rise is negative 1, and then our run is 2. So we're going to first start with that y-intercept, negative 4. So we can go to negative 4. There's our y-intercept right there. And then our rise is going to be negative 1, and our run is 2. So if we rise negative 1, that actually means we go down 1, and then we're going to run over 2. 1, 2. So we get that point, and then we could do it again. Fall 1, run over 2. And then take our ruler and draw our line. And then on the end of our line, draw on those arrows. The last one to graph is this orange one. So I can see for that one, again, the slope is going to be the same as the previous. We have a rise of negative 1, and then we are going to run 2. And our y-intercept is plus 1. So let's go all the way up to plus 1. That's right here. So our rise is negative 1, so we're going to fall 1. And then our run was 2, so go over 1, 2. So we're right there, and then we could do it again. Fall 1, run over 2, and then draw our line through our points, and then our arrows at the end of the line. So with that green one and orange one, those two seem to have the same slope too. They're pointing in the same direction. But if I would compare them to the red and the blue, it looks like they make a 90-degree angle with the red and the blue one. So we're asked just here at the bottom, what do you notice about these lines? We could say that the red and the blue line are parallel. We could also say that the green and the orange are parallel. We could also talk about how some of these lines are perpendicular. So if you picked maybe the blue line and the orange line, we could say the blue line and the orange are perpendicular. And that depends on what you pick, like the red and the orange. If we'd look at those two, red and orange, those are also perpendicular, or red and green, or even the blue and the green are perpendicular. So it just depends on which kind of lines you picked. But that is something that we could say about the lines. So next we're going to get into some characteristics for parallel and perpendicular lines. So first we're going to look at parallel lines. So parallel lines, it says do not blank. So looking at these lines, they never cross or intersect. So we're going to say they do not intersect. And intersect is just a fancy word for saying that they cross. Then it says parallel lines have the same blank but different blank. So if we look at these again, they seem to be having the same kind of angle, or the same slope is what we called it. So they have the same slope, but they have something that is different. And we've been talking about intercepts in previous videos. You could have, say, a y-intercept, that would be right here, or x-intercept. They're going to have different intercepts. So we can put, but different intercepts. So with these two examples, with this one, each of the slopes on these two, the slope is m, which it's 2, so it's just 2 over 1, rise 2, and then move over 1. With these two, the slopes are undefined, and it says right there, so the slope is undefined. So both of those slopes have an undefined slope. That means you actually can't calculate it, it's just straight vertical. And a notation you guys might have seen before to show that two lines are parallel, you put these little arrows on here, and if it has one arrow, the other one also has to have one arrow to signify it's in the same direction. Or if you'd use two arrows, then the other one would also have to have two arrows. So that's all for parallel lines. Then we got some characteristics for perpendicular lines. So with perpendicular lines, they are going to intersect at, and then we got a blank. So we said the angle that they made, you can see it right here. We even got the marker on there. They are going to intersect at right angles. And a right angle, all a right angle is a 90 degree. And then this next line, it says that they have slopes that are blank of each other. So let's maybe look at this example here to try to figure out how the slopes are related. So the slope of this first line here, the red line, it went down 1 and then it ran over 2. So that was a slope of minus 1 over 2. The second blue line is going up 2 and then over 1. So that was up 2 and then over 1. So our rise over our run, that's 2 over 1, which if you simplify that is 2. So how are these two related? We can see both of them have 2's. This one's negative, this one's positive, and they both do have 2's, but this one's in the denominator, this one's in the numerator. So for how these two are related, what we call this is they are negative reciprocals. They are the opposite sign of each other, and one of them has been flipped. This is 2 over 1, this one's 1 over 2. So let's write that in the blank. They are negative reciprocals of each other. Next, we're going to look at some examples where we figure out whether lines are parallel, perpendicular, or neither. So to figure that out, what we need to do is find the slope. And to find the slope, we are going to convert into our y equals mx plus b form. So convert to y equals mx plus b. Because remember that m there, the m was our slope. So with this first one here, just looking at that one, I'm going to get it into that form. So I'm going to subtract an x and add a 4 onto both sides, and I'll do that on this side, subtract an x, and then add a 4. So on this side, those are going to cancel out, and then I only have a 2y equals a negative x plus a 4, and then I still got to get rid of that 2 in front of the y. So divide by a 2, and then divide every other term also by 2. So these will cancel in the front, and in the very back, the 4 over 2, that's just going to equal 2. So all I have left is y equals, and then this right here, we have negative and there's a hidden 1. So it's negative 1 over 2. So negative 1 over 2. And then put your x, and then go plus 2. With the second one, I'm just going to write it over here. So I had 2x plus 4y plus 1 equals 0. And we're going to subtract a 1 and subtract a 2x from both sides. So subtract 2x, subtract a 1. Those are going to cancel out right there. So I only have a 4y equals a minus 2x minus 1. And then get rid of the 4. We got to divide by 4. So divide by 4 on every term. They'll cancel out right here. And we can also simplify this one. Negative 2 over 4. That'll just be negative 1 over 2. Just divide the numerator and denominator by 2. So I have y equals negative, and it was 1 over 2. So that's negative 1 over 2. Then put our x. Then minus 1 over 4. So I'm just going to circle those slopes. This was the slope for that one, and then this is the slope for the second one, and the slopes are the same. So we can write that they have the same slope, and then because they have the same slope, that means that they are parallel. The second one here now, again, we're going to change them into y equals mx plus b. So I'm going to get this y here by itself. So I am going to subtract 3x and subtract a 1 from both sides. Another way to do this is if you want to move those to the other side, you can move them over, but then the sign is going to change. So I'm just going to write that sign is going to change. So I'm going to have negative 2y over here, and then on the other side, the 3x moved over, so it's now negative 3x, and the 1 moved over, so now it's minus 1. So that's a lot quicker than writing all of these plus or minuses above. When you move it over, just change the sign. And then we got to get rid of that negative 2 in front of the y, so divide by negative 2. And then on the other side, we can do the same. In front here, those are going to cancel. And we could also cancel these negatives. All of those are going to cancel. So we get y equals 3 over 2, and then an x. And then it was a positive 1 over 2. Looking at this second one, I'm going to just rewrite it over here on the right. And then I'm going to move these two over to the other side. The sign's going to change when you do that. So we got 3y equals 2x moved over, so now it's minus 2x. And the minus 2 moved over, so now it's plus 2. And then we'll divide by 3 to get rid of that 3 in front. It's going to cancel in front there. And we're left with y equals negative 2 over 3x plus 2 over 3. So circling the slopes, this first one, the slope is 3 over 2. The second one, the slope is negative 2 over 3. So one of them is positive, one of them is negative, and one of them is 3 over 2, and the other one is 2 over 3. So it's been flipped. So in this case, we could say that the slopes are negative reciprocal. So slope is negative reciprocal, which therefore, if they were negative reciprocal, that told us that they were going to be perpendicular. So we just got one more example here, number 3. If you want to pause the video and try to do this one on your own, you can pause it and try to do that now. So again, the steps are the same. We're going to try to isolate this y, get it into y equals mx plus b form. So I'm going to move over this 3 and move over this x. So I'm going to have negative 2y equals negative x minus 3. So they both move over, signs change. Then get rid of this negative 2. So divide everything by negative 2. The negative 2's are going to cancel in front. These two negatives are going to cancel, and these two negatives are going to cancel. And there's also a hidden 1 there. You can write in the 1 if you find that easier. So we are left with y equals 1 over 2, then an x, and then it was a plus now, 3 over 2. Looking at this second one, I'm going to move that 1 over and move the x over. So when those move over, they're going to change sign. So it's going to be a minus x now over here, and a minus 1 over here. And then to get rid of the 2, just divide by a 2. Remember, there's that hidden 1 there. And these 2's here are going to cancel. So we get y equals negative 1 over 2, 2x minus 1 over 2. So circling the slopes, this one, the slope is 1 over 2. Circling the slope of this one, it's negative 1 over 2. So I can see that the signs are opposite. This one's positive, this one's negative. So it's kind of like this one, where they're opposite signs, but they didn't flip like the second one. In this one, it's 1 over 2, and then it's still 1 over 2. So it didn't flip, so it's not perpendicular, and these are not the same either, so they're not parallel either. So we can say that these slopes are not equal nor negative reciprocals. And then because of that, they are neither parallel nor perpendicular. The next thing we're going to be looking at is writing an equation involving a parallel line. So it says write the equation of a line in all three forms. So we're talking about our y-intercept form, our slope-intercept form, and our general form. So it has to be parallel to this equation, and it has to pass through the point 1 and negative 7. And then lastly, we're going to sketch a graph. So if it is parallel to this, that means that it's going to have the same slope as this. Again, that was because it was parallel. So I'm going to find the slope of that one, and then I'll know what my slope needs to be. So I'm going to start with 2x minus y plus 4 equals 0. And then just like the last question, we're going to move these two to the other side. So I got minus y equals a minus 2x and a minus 4. Sign changes when they move over. And then to get rid of this negative in front, just divide by a negative on every term. These will cancel, and these will also cancel. So we get y equals 2x, and then it's now plus a 4. So I can see my slope is right there. My slope is going to have to be equal to 2, and that's what our m is. So I now know what m is, and we were also given this point up top right here. So whenever we were given a point, I'm just going to write it down here, 1 and negative 7. You want to label the point, so I'm going to call it x1, y1. So we had done this in our last video when we had slope and a point. What we did was we put it into our slope point form. And our slope point form was y minus y1 equals m times x minus x1. And then I'm just going to fill that in with the point and the slope that we had. So we're going to have y minus, and then y1 was negative 7 equals, m was a 2, and then x minus, and x1 was a 1. And then we're just going to start to simplify. So these two negatives, that can give me a positive. So that's y plus 7 equals 2 times x minus 1 in brackets. So that right there is our slope point form. To get it into our next form, our slope-intercept form, we're just going to move this 7 over to the other side and then get rid of any brackets that we have, because our slope-intercept form, just to remind you, it looks like this, y equals mx plus b. So everything's all on one side except for the y, and there are no brackets. So when we move that 7 over to the other side, there's only a y on this side, and then we have 2 times an x minus 1. And then the 7 moves over, so it changes sign. It's now negative 7. And then to get rid of the brackets, we're just going to distribute in. So we're going to have a 2 times an x, so that is 2x. Then we'll have 2 times negative 1, that's negative 2. And then minus 7. And then the minus 2 and the minus 7 we can put together. So we're going to have 2x minus 9. So that is our slope-intercept form. The last form was our general form. So general form, we wanted to think of the army. It's all lined up nicely on one side. So I got to move this y over to this side now. And when it moves over, it's going to change to a negative. So we're going to have 0 on that side. And then we'll have 2x. And then the y moves over. So it's minus y. And then a minus 9. And then with our general form, we just had to make sure whatever was in front of the x, it couldn't be negative, and it also couldn't be a fraction. So in this case, the 2 is okay. That is our general form final answer. Now that we've gotten all three forms, we're just going to go back up and do the last thing. It said we had to sketch the graph. So to sketch the graph, I'm going to use the one point that it had, which was 1 and negative 7. So I'm going to go over 1 and then down negative 7. So that is located right there. And then I'm going to use my slope, which my slope we had right here was 2. So if we had a slope of 2, 2 is like 2 over 1. So our rise is going to be 2, and our run is going to be 1. So I'm going to rise 2, 1, 2, and then run over 1, and then we get another point. And we could continue that, rise 2, run over 1. You could do it again, rise 2, run over 1. I think you get the idea. All we got to do though now is draw our line through our points. And then at the end of the line, just put your arrows on there. So that one is all done. That one involved a parallel line. Moving to the next one, it's going to be the same type of question, but it is going to be with a perpendicular line. So it says, write the equation of a line in all three forms that is perpendicular to, and then we're given this equation, and it has to pass through this point 8 and negative 6. And then lastly, we're going to sketch the graph. So if it is going to be perpendicular, remember with perpendicular, we said it was going to have a negative reciprocal. So negative reciprocal. So that means when we find our slope, we're going to have to change the sign and then also flip it. So let's start to find the slope. So we're going to start with our equation here and then use that to find the slope. So let's get it into our slope-intercept form. So I'm going to move the 4x to the other side and move the negative 12 to the other side. And when I do that, they're going to change signs. So I'm going to have a negative 4x on the other side and then a positive 12. And then I can see the slope from this already. The slope is negative 4. So let's just write that. Slope is negative 4. That's like negative 4 over 1. So if we want to be perpendicular, that meant that we're going to have to take the negative reciprocal. So our slope is actually going to be positive, and flipping it, it's going to be 1 over 4. So we now have our slope and our point. It was 8 and negative 6. I'm just going to label that. We'll call it x1, y1. So we're going to take that and plug it into our slope point form. So that's y minus y1 equals m times x minus x1 in brackets, and then just plug in. So that's y minus y1 is negative 6 equals m is 1 over 4. Then we have x minus, and the x1 was and 8. So now that we got that, we can start to simplify some things like those two negatives. So I'm going to have y plus a 6 equals 1 over 4 times x minus 8. And that right there is our slope point form. So we got our first form. Next, we're going to find our slope-intercept form. So to do that, we're just going to move over the 6 and then get rid of any brackets that we have here. So when we move over that 6, it's going to become a negative 6. So everything else will stay the same, but the 6 comes over. So it's going to be negative 6. And then to get rid of the brackets, just distribute in. So we'll have y equals a quarter times x is a quarter x. And then a quarter times negative 8. Think of 8 as 8 over 1. So if you multiply the tops, 1 and an 8, that's going to give you negative 8. And then if you multiply the bottom, 4 times 1, that's going to give you a 4. And then we just have that minus 6. And then looking at this here, if you have 8 over 4, you can simplify that. 8 over 4, that's just equal to 2. So in the last step, we're going to have y equals a quarter x, and then I can put the negative 2 and the negative 6 together. That is negative 8. So that is our slope-intercept form. Lastly, we just got to get the general form, so move the y to the other side, and then we got to make sure that whatever's in front of the x, it has to be positive, and it also can't be a fraction. So I'm going to have 0 on that side when I move the y over, and then the quarter x, and then the y moved over, so it's minus y, and then we had minus 8. So to get rid of this fraction in front of the x, they're dividing by 4, so we are going to multiply by 4, and we have to do that with every single term, even the 0 over here. So the 4 and that 4 are going to cancel, and then I'm going to have 4 times 0, that's just 0. This term, I just got 1 times x, so that's x. Then I got minus 4 times y, that's 4y. And then minus 8 times 4, that's minus 32. So that is our general form. And again, lastly, we're just going to go back up and we're going to graph this. So we had the point 8 and negative 6. So 8 over is right on the edge of my graph, and then 6 down is going to be right on the edge of the graph, right there. So from that point, we're going to use our slope, and our slope was right here. So our slope is going to be a rise of 1 and then a run of 4. Now if I rise 1 and then run over 4, I'm going to be off my graph. So what you can do, instead of going kind of off the graph like that, you can do the exact opposite and fall 1 and then run over to the left 4. And then we'll get a point over here, and that point will be on our graph. And now once we've got that point, now we can draw our line. So once we've got our line, we're going to draw our arrows, and you can see that I didn't go through this point here because I didn't have my values to hop perfectly. So what you want to do, if you did do that, just erase that. Only try to move your hops on your graph. That way it's going to be way more accurate. The very last thing we're going to look at now deals with comparing slopes. So it says we're given slope 1, it's 10 over 3, and then a second slope, slope 2, it's 8 over n. And it says, what must n be for the lines to be parallel and perpendicular? So I know if they're parallel, these two slopes have to be equal. And if they're perpendicular, these two slopes have to be negative reciprocals of each other. So for parallel, if they're equal, I am going to set them equal. So 10 over 3 equals 8 over n. And to solve something like that, you might have seen something like this before. What you can do is cross multiply and divide. So I'll cross multiply these two and then divide by the one across from the n. So n is going to equal, the cross multiply was 3 times 8, and then divide by the one across from the n, that was 10. And when you calculate that, you're going to get 2.4. For the second one, when it's perpendicular, remember we said perpendicular was negative reciprocal. So if the slope was 10 over 3, to be negative reciprocal, it's going to have to be the opposite sign, so negative. And then reciprocal, we flip. So we got 3 over 10. So now I'll take negative 3 over 10, and I can set that equal to 8 over n. So again, we can do our cross multiply divide. So I'm going to cross multiply those two, and then divide by the one across from the n. So that is going to give me n is equal to cross multiply 10 times 8 divided by the one across from the n, negative 3. And when you calculate that, you're going to get negative 26.6 repeating. So that was our last example that we were doing. Our textbook questions I just got here at the bottom. So we're working on page 390.